Alright, notes number 4, the fundamental counting principle. We're going to start our Unit 5 on probability now, and the first thing we're going to talk about is the fundamental counting principle. So this first example says that the counting principle is all about choices we might make given many possibilities. Suppose you forgot to do your laundry, which most of you probably have done, and you're only left with dirty clothes. So you got all this dirty clothes, but you have 2 pair of pants and 3 shirts to wear. Now it says, how many different choices do you have for an outfit? Well, we have some pants here and some shirts here, so we can say, well, I can wear these pants with, maybe I want to wear this shirt. So we can say that's an outfit, but I don't want to wear that shirt and like how it fits, so I can put this one. But then you say it doesn't really go with these pants, so I'm going to wear this, so that's a whole nother outfit. So we just went through 3 different outfits. But then you say, not this shirt, but then we put this on, don't like how the skirt goes, so you go back to your pants. So now we just made 6 different outfits. So what we're going to be looking at is how many different outfits we can make. So what we want to say here is that given this, we have pants. So we have pants 1 and then pants 2. So pants 1 would be the jeans and pants 2 would be our skirt. So now we also have shirts. So we have pants 1 and pants 2 and then shirts. So we have shirt 1, shirt 2, shirt 3. Well, here's shirt 1, here's shirt 2, and here's shirt 3. So what we can do is we can say, well, with my pants 1 or my jeans, well, I have 3 options. I can wear shirt 1, shirt 2, or shirt 3. So we have 3 different options to wear with our pants. And then we can say the same thing with pants 2. So I can wear shirt 1, shirt 2, or shirt 3. So that means we have a total, if we count these, I have 1, 2, 3, 4, 5, 6. There's a total of 6 different outfits I can wear. Now some are going to look better than others, but we have a total of 6 different outfits. And if you notice, there's another way that we can do it. If we say, well, I have 2 pairs of pants and I have 3 shirts, well, 2 times 3 will give us our 6 different outfits. So let's take a look at example 2 here. Example 2 says, suppose you go out to breakfast and the menu says you can have pancakes, waffles, or eggs to eat. Sides are either home fries or toast, and to drink you can get juice, coffee, milk, or hot chocolate. How many different choices of food, side, and drink do you have? Well, the menu we have to eat pancakes, waffles, or eggs. So I know I have my pancakes. This is to eat. I have my waffles, and I have my eggs. And then it says to drink, or we have a choice. The next thing is it gives us a choice of sides. So my sides, I can either have home fries or toast. So that means if I choose pancakes, then I have a choice of either home fries, which I'll abbreviate as HF, or I can get toast as T. But I didn't want pancakes, I wanted waffles, so I can do the same thing here. I can get home fries, or I can get toast, or if someone wanted eggs, they could get home fries or toast. So this is our side. But then they also get a choice of a drink. So the next thing it says to get a choice of a drink. So we can have juice, coffee, milk, or hot chocolate. Well, then we have our drink. So if we look at our drink, well, I have 1, 2, 3, 4 choices. And here, 1, 2, 3, 4 choices again. Now, I'm running out of room to write all these. So we know that our drink, we can have a juice, a coffee, a milk, or hot chocolate. Juice, coffee, milk, or hot chocolate. Now, that's getting very tedious to do. I can't even read what I'm trying to write anymore. So there has to be a better way. Well, if I notice with my to eat, I have two choices, or sorry, I have three choices to eat. So we have three choices. Now for our sides, we have two choices, and then for our drink, we have four choices. So instead of trying to write all these out, you can't even read what the drink is. We don't have enough space here. Well, if you notice, what we're really doing is multiplying all these together. We know that 3 times 2 is 6, 6 times 4, so there's 24 different options. And that is what the fundamental counting principle means. So for the fundamental counting principle, it states that for a sequence of two events in which the first event can occur in m ways, because we don't know, so m is just our variable. And the second event can occur in n ways, because we don't know that one either. The events can occur m times n ways. So what we're really saying is that we're going to take event 1 times event 2. If we have more, times event 3, ... So we could have infinite events, but what we're going to do is we're just going to keep multiplying the different events. This example here had event 1 was eat, event 2 was our sides, event 3 was our drink. So we multiply those three values together. So that's the fundamental counting principle. Now if we look at these examples here, example 1, this is a deli has a lunch special which consists of sandwich, soup, dessert, and a drink. For $4.99, they offer the following choices. Well, we notice for a sandwich we can have 1, 2, 3, 4. So we have 4 choices. For soup, we have 3 choices. For dessert, we have 2, cookie or pie. Drink, we have 1, 2, 3, 4, 5. Now, how many lunch specials? Well, what we want to do is we want to do event 1 times event 2 times event 3 and times event 4. Event 1 being our sandwich. So our sandwich. Event 2 is our soup. Event 3 is the dessert. Event 4 is our drink. So we're going to have 4 times 3 times 5 and times 2. These event 3 and event 4 are switched. 4 times 3 is 12. 5 times times 2 and then times 5. We'll fix that. So 4 times 3 is 12. 12 times 2 is 24. 24 times 5. So it's 120 different ways. Example 2. You're taking a test that has 5 true and false questions. If you answer each question with a true or false and leave none of them blank, how many ways can you answer the whole test? Well, it says there's 5 questions. So since it's 5 questions, there's the 5 events. Well, there's my 5 events. And first question 1. So question number 1, true or false, well, that's 2 choices. Question number 2, true or false. Number 3, true or false. Number 4, true or false. And question number 5 is also true or false. Now, it tells us to multiply these. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So there's 32 different ways to answer the multiple choice test. When we look at example 3, a company places 6 symbol code on each unit of product. The code consists of 4 digits followed by 2 lowercase letters. How many different codes are possible? Well, it says that it's a 6-digit or 6 symbol code. Well, 1, 2, 3, 4, 5, 6. Okay? So now it says the code consists of 4 digits. Well, digits are 0 through 9, which is actually 10 numbers. If you don't believe me, we can go through and count. It's not 9 numbers, which a lot of people think, because we have to add in that 0. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 plus the 0 is going to be 10. So we have 10 numbers to choose from. So the first 4, we have 10 numbers to choose from, whether we want to choose 1, 8, 6, and 0. So we have 10 different numbers. Now, followed by 2 lowercase letters, well, we know that there's 26 letters in the alphabet, so we have 26 choices to choose from. So for this password, or this symbol, it's 10 times 10 times 10 times 10. We go to 10 to the 4th power times 26 times 26, and it gives us 6,760,000. So we have 6,760,000 different combinations for codes. So they can have 6,760 different products. Example 4. 1 quarter, 1 dime, and 1 6-sided die are tossed. How many results are possible? Well, we know that we have 1, 2, 3 different events. We have a quarter, a dime, and our die. Well, a quarter, it's either heads or tails. That's 2. A dime is either heads or tails. So that's 2. And a 6-sided die, well, that's 6 sides. 2 times 2 is 4. 4 times 6 is 24 different possibilities. And then the last example we have, next semester you're going to take one science, 1 math, 1 history, and 1 English class. So just looking at that, well, we know we have event 1 is science, event 2 is math, event 3 is history, and event 4 is English. That didn't work out too well. Is English. So we're going to have 4 different things going on. So it's event 1, event 2, event 3, event 4. So you have 4 different science classes, 3 different math, 2 different history, and 3 different English. So we multiply these together. 4 times 3 is 12. 12 times 2 is 24. And 24 times 3 is 72 different selections. And that is the fundamental counting principle. We just take the events in the problem and we multiply them.